Title of my presentation is Ubiquitous Smartphone-Based Bioluminescence Detection. My name is Iwan Bae. And the need for this technology is, in the United States, there are lots of foodborne illnesses that's occurring. And because of that, there's a lot of 48 million cases, hospitalization, and even 3,000 deaths based on the previous reports. Now, current instrumentation related to these test methods are very time-consuming because you have to have your sample that is collected either by the farm or processing or like supermarkets have to be sent out to the central lab to actually be detected. So there's a gap between the sample collection and the result. By the time after 1 or 2 days when you get your result, the food will be probably already consumed. So what we're proposing is we're trying to get a rapid on-site detection to get a better time to result of our samples. Now, the method we're proposing is based on using a smartphone as a bioluminescence detection. So bioluminescence is a very, very weak signal. So they require specialized detectors such as photomultiplier tubes. But now what we're proposing is, we all know that smartphones are everywhere. We have designed a hardware and we also developed a special software to actually increase the sensitivity of the detection mechanism of the commercial smartphones. So this way we will be able to measure the luminescence signal, which if you just bring your normal smartphone that will not be able to do it, but with the help of those two technology, we actually show that we can actually measure the signal from the bioluminescence detection signal. The sample we used was a Pseudomonas M3A strain. So in the legal landscape, we have already filed 2 disclosures with 1 U.S. provisional patent. And on the long term, many researchers in the United States and over the world are using smartphone-based instrumentation because of their powerful capability and portability. But most of the instrumentation who's using to provide to detect very, very low level of light signal will require this kind of a hardware and software adjustment because the commercial at this point, the commercial point is too less sensitive to actually detect these kind of weak signal. So we think that the proposed hardware and the software method we have utilized in our case will be applicable in the diverse and different cases. We're trying to measure the weak signal from a bioassay on different types of fields. Thank you.